Good afternoon, everybody. My name is Kurchi Hasra, and I work on the JDK Core Libraries team. And this is Stuart Marks, my colleague in the same team. And we're going to talk about essentially warnings today. Okay, before I start on, yeah, sure. How many of y'all have idea about -Xlint all, -W error on the slide? Okay, some of you don't. Perfect audience. So -Xlint all is an option that you send to the Javac compiler to ask it to let you know of any warnings that your code has. And -W error tells the compiler that if there's any warning, flag it as an error and don't compile my code. Given that, how many of you will be ready to take up this challenge? I hope it's very few so that I can talk and lecture here. So yeah, I'm not going to talk about this kind of warning. So what are we going to talk about today? Well, first of all, I'm going to try to motivate you all so that you'll stay awake and actually listen to me. And I'm going to talk about why you should pay attention to some of the warnings that Javac tells you about. After that, I'm going to talk about a little about what kind of warnings Javac emits, what are their importance, and I'll talk about a little more in detail about some of the more common ones. Then I'm going to talk about what happened when we in JDK development took up that challenge that I was talking about, and what did we see in our own code, before we ask everyone else to fix their warnings. So I'm going to talk about that, and then some more complicated warnings and some more complicated scenarios that you might come across if you are trying to fix your warnings. Before concluding, I'll talk about how you should not fix your warnings. But we'll get to that. So to start off, why are warnings important? Well, let's take a step back. Why are compilers important? Well, compilers, besides compiling your code, it's also the first line of defense that you have against anything questionable or suspicious going on in your code. So if you're using any deprecated methods which are not safe to use, if you're using any questionable constructs, or even if you have some kind of error that has crept into your code because of, we are all human beings, so we all make errors, the compiler is going to let you know about these. So when the compiler is very sure about what you're doing is wrong, if it can prove it, it gives you an error. But then there are situations when the compiler is not able to prove it, but then it's a little suspicious about what you're doing. And that is when it'll let you know that, hey, there's probably something wrong going on. Why don't you check it? And it communicates to you via a warning. So for example, if you declare a list of string, say list A, then the compiler is very sure that what you need to put into the list is a string, and what you get out of the list is a string, so it should be stored in a string. So, if you're doing something else like adding a number there or something like that, then the compiler can flag an error. But then if you're using a raw type instead of, a generic list of string, then the compiler has no freaking clue about what you're supposed to put into it. And if you're doing something, suspicious over there, the compiler is going to give you a warning in that case. Also, if you start fixing your warnings, you'll see that most of it is probably noise, but many a times it'll help you find out about potential bugs or prevent future bugs. You'll see that if you keep fixing your warnings, you'll get cleaner code, and which is also safer. So, I have a small code snippet over there which switches on, say, an integer bank balance, and it prints out, different statements depending on the value of bank balance. But then you see you have a missing break statement here. Well, we all know that we should put a break statement over there, but we all have done that mistake of not putting that break statement. But had the developer paid attention to the warning that Javac generates in this case, he could have avoided this pitfall. Also, especially the Javac compiler lets you know about any new language features that are available for you to use, and then it flags any kind of deprecated usage that you're doing. So, 10 years ago, in prehistoric times, if you were dealing with a list of strings, then probably you would use a vector to get your strings. Who knows what's there in the vector? You would enumerate through it, you would do casts, and then you would return another vector. Who knows what's there in it? But now you're probably going to write something like this, where you have a list of string, and you look at it, and right away you know it's a list of string. And you do whatever processing you're doing inside it, and what you return is a list of string. So this is much safer. I hope I've motivated you all enough, because it's all downslope from now. I'm only going to talk about warnings. So moving on, just to give you an idea about how you get to know about warnings, say you have a simple code snippet where I have a class foo with a method m, which declares a list LST, and it assigns a new array list to it, and then it adds a simple string to it. If you run Javac on this, the compiler is going to tell you that, hey, something unsafe is going on over here. Why don't you check with some compiler flag -Xlint unchecked? Okay, I go a step forward. I use -Xlint all, and the compiler tells me, okay, you're using two raw types, list and array list. It's in your best interest that you don't use it, and you're probably doing some unsafe operation when you're adding a string to it. Now, I know most of you probably don't use the command line Javac. Most of the IDEs have some kind of an option to enable a Javac warning specifically. For example, in NetBeans, you can go to your options, hints, and then enable standard Javac warnings over there. And once you do that, NetBeans is going to show you a light bulb and a warning sign, and you hover on that, and then you get to know what the warning is. This is a list of the lint warnings that Javac gives you. So lint warnings is basically anything suspicious going on in your code. You have, finally, which tells you if your finally block is not going to end properly. You have div0 if you're doing a division by 0, and so on. These three, specifically unchecked and raw types, is you get it when you're using generics or when you're not using generics. And cast is kind of related to them, so I'll be talking about them later on. Before that, I'll be talking about these four: static, deprecation, serial, and fallthrough, because in our experience, they are the more commonly ones that you see. Fallthrough. So when do you get a fallthrough warning? If you're using a switch case block and your case is not terminated by either a return statement, or it does not throw a new exception, or you don't have a break statement over there, you are going to get a fallthrough warning from the Javac compiler. Why does Javac communicate about this to you with a warning? Because most of the times, it's a programming error. Sometimes you want your logic to fall through to the next case, but most of the times we miss, inserting a statement over there. So, I have just a simple example. If, value of val is 1, we do something. Value is 2, we do something else. Otherwise, we do something default. And since we don't have a break statement right after whatever we do in case 1, we're going to get a warning over there. There is one occasion, though, when the compiler doesn't give you a warning. That is when a case is not followed by any code, and you simply fall through to the next case. Because this is a common practice used by developers to group multiple values into a single case. So that is why this is not flagged as a warning. Now you'll feel that oh, this is a simple thing. Probably this won't harm me. This looks harmless. But let's look at an example where things might go wrong. So we are switching on probably an integer val, And then if its value is 0, we call the method throw an exception, whose job is to throw a new, customized exception. If it's case 1, we do some normal processing. For default, we do some default processing. Now, what might go wrong here? I mean, of course, there's a fall-through warning there, but then what might go wrong in the logic? Well, no. What might happen is if you override throw an exception, there's no guarantee that whoever overrides throw an exception will be throwing an error over there. So, in that case, what happens is your logic will just fall through to case 1. A cleaner way of doing this would be, you throw an exception over there, probably get an exception from another method, that's fine, but you actually throw that exception over there. You don't get the fall-through warning, and you're guaranteed that even if someone overrides that method, then he will have to return an exception over there. Yep.
Is final or,
yeah, if you say it's final, then it's a different. Yeah. Moving on. Deprecation. Most of us know we get a deprecation warning when we are using a deprecated method, a deprecated class, or a deprecated field. Usually these are unsafe to use. That is why the language tells you, don't use these. Or if you go to the Java doc of these deprecated methods, we'll recommend to you, what other methods you can use in the place of these methods. Just for coverage, some examples. Thread.suspend, thread.stop, thread.resume are all deprecated because thread.suspend is inherently deadlock prone. If you're not using thread.suspend, then what do you use thread.resume on? And thread.stop leaves your program in an inconsistent state. However, so if you use them, you get deprecation warnings. But if you've if your application is designed to use them, the only way to get rid of them is by restructuring your application. String.getBytes, data input stream.readline are some other example where the conversion between bytes and characters are not properly handled here. So if you do use them, and if you're using ASCII, you're fine, but otherwise your data might be corrupted. Static, very simple. This warning is issued when you call a static method by using a reference to an instance of the class instead of the class name itself. So if you see the example, we have a class static demo, which has a static method do not call with instance. And you go ahead and you call it with the instance demo. You get a static warning over there. What you're supposed to do is call it with the name of the class, like the last line there. Well, this also kind of looks harmless, but let's look at an example how this can cause errors in logic. So we have a class foo, and it has a static member value. You have a static function setValue, which basically sets value to whatever parameter you pass, and you have another method getValue, which returns value to you. Now, if someone starts calling this with an instance variable of the class, like foo1 equal to new foo, foo2 equal to new foo, and then he calls foo1.setValue to first, foo2.setValue to second, and once he calls foo1.getValue, he's probably expecting that it's going to return first to him. However, since it's a static member and those are static methods, you get second, right? Because value is set to second because it's a static method. So, you might just be surprised by what you get back. Serial. So this warning is issued when you have a class which implements serializable and you have not declared a SerialVersionUID for that class. Now, why is it so important to declare a SerialVersionUID? So when you're serializing, what happens is, say you have a sender, which serializes an object before sending it to the receiver. And the receiver will receive the object, deserialize it, and do whatever it wants to do with it. So when the sender is serializing the object, what it's going to do is it's going to pack into the object the class file version that it's using. Perhaps something like 87422, blah, blah, whatever the number is there. And it's going to pack it into the object before sending this object to the receiver. Now, once the receiver receives the object, it's going to deserialize it. And while in the process of deserializing it, it's going to check that the class file version that the receiver is using is the same as the class file version that is packed into the object. If it is not, it's going to give you an invalid class exception. And SerialVersionUID is essentially this class file version that's packed into the object, right? Now, in case you don't declare a SerialVersionUID in your serializable class, the compiler is going to generate a default one for you. However, it's discouraged to use that default value because even with changes that are perhaps innocuous, that you feel are not that great or important, your SerialVersionUID will change in surprising manners, and you'll get invalid class exceptions. You'll be surprised by what you see, basically. What we do when we see such warnings, we use the SerialVer tool. It's there in your JDK bin for you to use. And you can use that with the earliest class file version that you want to be compatible with. And then it's going to give you an appropriate serial version for you to include in your class. Moving on, what happened when we took up the challenge ourselves? So around 1.5 years back, we thought that we'll see how we are doing with warnings ourselves. And just to give you a background, I'm just talking about the JDK repository in OpenJDK. It majorly deals with the core libraries. There are around 8,200 Java files, and we are only talking about Java warnings over here. We are not talking about native code C warnings. And there are around 2.6 million of code there. And the compiler that we used was Javac, and we enabled all warnings. And we got 13,500 warnings. Well, yeah, we were surprised as well. And so this is a distribution of the kind of warnings that we saw. There's raw types, unchecked, deprecation, serial, cast, static, fallthrough, and a small number of other warnings. And if it's not blatant enough yet, yes, there are 71.3% of them are raw types and unchecked, right? So why do we have so many warnings in our own code? Are we sloppy programmers here? We don't care what we are doing. We just write code. Well, turns out no. So if you analyze it, we try to analyze it. So what happens is, the language changes. The platform that we are using, it changes. It gives you new features, and to make use of those features, we change our API as well. And then once you change your, even y'all probably will change your API just like we do. And once you change your API, you need to change the implementation as well. And when these three things don't go hand in hand, you'll have 13,500 warnings. So like, for an example, before Java version 5, we virtually had no warnings. But then in Java 5, generics was added. Most of our API were updated to use generics, but then the implementation was not. And then on top of that, we started generating mandatory unchecked warnings so as to help people with their code migration. So, with the same code, nothing has changed, probably some API updated. We have, several new warnings now. Covariant return types were also added in Java 5. What are covariant return types? I'll come back to it in some time. But then we also, again, updated some of our API to take advantage of this. And then, the implementation was probably not updated to take care of that. And then we had several of redundant cast warnings because of that. Java 7 expanded on lint warnings. So if you use Java 6, you don't get raw types warnings. If you use Java 7, same code, you start getting raw types warnings. So, nothing has changed. The code is same, but we have so many additional warnings right now. So we are trying to fix these warnings, and I spoke, some of the examples that I spoke about before are from what we came across and how we solved those problems. And now I'll be talking about some of the examples in generics that we came across. Just to give you a background, if you have a code of this kind, something similar to we saw in a few slides back, you have a list LST, and you are assigning a new array list to it. You are adding a simple string to it, Duke, and then you're just retrieving back the string that you added just before this line, and you're casting it to string. Now, the first line will give you a raw types warning. It'll actually give you two raw types warnings for list and array list. And the second line will give you an unchecked warning. Now, a raw types warning is straightforward. It's given to you when you're using a raw types instead of a generic type that you can use. When is an unchecked warning given? An unchecked warning is given to you when neither the compiler nor the Java virtual machine can guarantee the type safety of the operation. That is when you get an unchecked warning. So how do we fix it? We try to add generics. We say list of string, LST equal to new array list. We use our brand new diamond operator. And then we add Duke to it. And guess what? We have added some more warnings now. We get redundant cast warnings. So we take away 500 warnings and then we add 300 to it. And then you have to go and worry about how to remove them. So the correct way to do it would be, remove that cast over there because you don't need that cast anymore. It's redundant. And this is what we are aiming for. So this is cleaner and safer code that you get to. Okay, that was easy. Next one. Okay, in the next example, we consider two libraries, library A and library B. A has nothing to do with B, B has nothing to do with A, except that B sends a list of string to A. We're just, imagining a scenario here. Now, how does B do it? It probably, instantiates an object A, and then it creates an array list, and then, it calls a method sendList to send that list. Now, B clearly is not using generics, and the developer at A suddenly has probably listened to my talk and has returned back and is motivated to remove warnings. So he wants to use generics now. Now, what does he do? Well, one option he has is change everything to generics. That's fine. But what about this method sendList? How does he deal with that? He could change the parameter to not take a raw type anymore and start taking a generic type. But then B will start getting a lot of unchecked warnings in that case. So probably A doesn't want that to happen. So the key points here is A knows that what it's going to get from B is a list of string. A does not want to change the argument of sendList for code compatibility reasons. And so A basically needs a method which is going to take a raw type and is going to give back a generic type, a generic list of string. So what A needs is a method of this kind. We have the method name probably is convert raw to generic. It takes a raw type. It converts it internally into a list of string, and it returns it back. What is a good way of doing this kind of a conversion is what we're trying to talk about here. So one way to do it is you assign list 0 to a list of wildcards. That allows you to go through each of the elements of list 0 one by one and check that all of them are instances of string. If not, you throw a class cast exception right away. Because you are anyway only going to accept a list of string. Once you do that, you can cast it to a list of string now. So you can cast the list of wildcard to a list of string now. This line will generate an unchecked warning. However, at this point of time, you are more intelligent than the compiler. The compiler has no idea about what list 0 contains, but you have made sure that list 0 contains only instances of string. So this cast here is perfectly legal. There's nothing wrong with it. And in such scenarios, it's okay to suppress that warning. So even if the compiler is giving you a warning, you know, okay, there's nothing unsafe going on here. All I have is a list of string, and you can go ahead and suppress the warning over there. Okay, moving on, next example. This is another thing we came across where you have to convert a set of question extends t to a set of t. Now, the first attempt, you'll be tempted to just assign it to a set of t. Will this work? No. Why? Well, generics are invariant, so set of t is not a supertype of set of question extends t. So this line here is going to give you a compile time error. The next attempt, the next instinct would be cast it. Right? So you have set of question extends t, set 0, and you cast it to set of t and assign it to, set of t. This is going to give you an unchecked warning. And now we're going to see why we get that unchecked warning. So just to recap, what are we trying to do here? We are trying to convert a set of wildcard extends t to a set of t. And how are we trying to do it? We are trying to cast it to set of t. Now, what's the problem here? Let's look at an example. There's a method print integers, which takes a set of integers an argument, and it's basically supposed to print out all the elements of that set that you pass to it. Okay, now we assign set arg, which is the set of integer that we've received, to a set of question extends number. So what you have here. So set 0, and so this set 0 and that set 0 is basically equivalent, right? So t here is number, right? So I'm just trying to make it, very equivalent to that so that it's easier for you all to understand. And then what we do, what we're trying to do is cast it to a set of number. So now what we have is set 2 is a set of number, but set 2 is nothing but set arg, right? However, now that set 2 is a set of number, it's perfectly legal for you to add a double to it because, double is a number. So what have you done? You have polluted the set. So, I am printing out this set over here, but you could have just returned this set, and whoever has passed that set to you has no idea that you've added a double to it. Probably he assumes you have returned a set of integer. He tries to, loop through each of the element, 1, 2, 3, 4, and then suddenly, boom, you have 1.0, and you get a class cast exception. So that is why that cast over there is unsafe for you to do, and so you get an unchecked warning over there. But the problem that crept in the previous example is that you were modifying the set later on. However, if you're very sure that you don't have to modify the set later on, this is a safer way to do it. You can call, there's a method unmodifiable set in collections, and you can just pass set 0 to it. And what unmodifiable set does is it gives you an unmodifiable view of a set of question extends t, which you pass it, and it returns you a set of t. So you can do something like this, but then, you cannot pollute set 3 anymore because you cannot change it. Covariant returns and cast warnings. So a few slides back, I told you all that I'm going to get back to covariant returns. So say we have a class foo, and so I'm trying to explain what covariant returns is here. So say we have a class foo with a method getMe, which returns back a foo to you. You have another class, bar, which extends foo. Now, before Java 5, any method of foo that bar overrides, the return type had to be exactly the same as the supertype had. But Java 5 onwards, the return type can be a specialization of the return type that the supertype has. So in this example, bar is overriding getMe, but it's not returning a foo like foo does. It's returning a bar, And this is legal because bar is basically a specialization of foo. So Java 5 onwards, this feature was added to the language. How did that lead to a number of redundant casts? Let's look at another example. So we have a class foo, which implements clonable. Now, the clonable interface has a method called, clone, which returns back an object. So if any class was implementing that interface, then if it was overriding clone, it had to return an object. And if you happen to use that method clone, then you would have to cast it back to the object. You'd have to downcast it. However, once covariant returns were added, we updated some of our API, and we updated it to something like this. So now, clone, instead of returning object, starts returning foo, which is perfectly okay because foo basically extends from object, right? So what happens is this cast now becomes redundant. So if you update your API and you don't remove that cast, you have a number of cast exceptions because of redundant casts. So what you need to do is, even remove that cast over there. Cloning arrays also, covariant return types were also applied for cloning arrays. So if you have an existing array and, we have an existing array, which is an integer array, and then you try to clone it, before Java 5, you would have to cast it to an integer array. What you would get back is an object array. However, Java 5 onwards, you do not need to do that cast because what you get back is an integer array. So here, even the API did not change, just the platform, the language changed, and again, we started getting additional cast exceptions. Okay, I'm done with my examples, so we've been working for like 1.5 years to reduce those 13,500 warnings, and it's not anyone's full-time job, but we put in some hours, and then we have a lot of community effort as well, and we've brought down that number to 7,133, which is around 47% reduction, and you're working towards 0. But the distribution has not changed a lot. It's still unchecked and raw types still dominate. Okay, how not to curb your warnings? Sometimes, you're very confident about what you're doing. You're very sure about what you're doing. You don't care about warnings, and all you want is the compiler should just shut up somehow, right? Good news, you have two options to do that, but what we tell you is use them with caution because, it might just lead to something untoward. For example, you can use @suppress warnings. So this is an annotation that you can use in your code to suppress any particular kind of warning. So what you say is, if you're very sure that, a fall through is supposed to happen, it's not a human error that has crept in, then you can do an @suppress warnings fall through. Now, this obviously does not solve the root cause, right? The reason for the warning is still there. But when necessary, you should apply it to the smallest reasonable scope of code that you can find, essentially because it will also suppress any future warnings that, that piece of code might have been giving you. So to make sense of what I'm talking about, we talked about this method a few slides back, convert raw to generic, where we were converting a raw type to a generic type. And there we said that this cast there at the bottom before returning the list is perfectly legal because we have done all kinds of check and we're very sure that it's a list of string. Now, so this is the kind of warning that you should suppress because you're very sure that, there's no problem here. And where do you suppress the warning? Well, you have a couple of choices. You could obviously suppress it over the entire class. Please don't do that. You could suppress it on the method, but The problem here is, say, tomorrow some other developer comes in and he starts adding an integer to list 0 before doing any kinds of check. That'll lead to a class cast exception. So the better thing to do would be suppress the warning right on that line over there, because you can suppress a warning on a declaration. Minus Xlint all, yeah.
There's a basic question, but can you also add something to the block of code, like a local scope, additional scope?
No, only on declarations. Yeah. If you don't want to change your code at all, and you want to just suppress one kind of warning, and you basically want to reduce the noise that the compiler is giving to you. Say for sure, let's say you have an application where you've used deprecated methods all over, and you are very sure you're not going to change that. You're not going to remove the deprecation warnings. But you want to see all the other warnings that your code is giving. So what you're trying to do is reduce noise over here. So this is another option that you can give to the compiler. You can say something like minus Xlint all, minus deprecation. So what you're telling the compiler is, give me all the warnings except deprecation. And this also, just like suppress warnings, this also does not solve the root cause. So you should use it with caution only when you're very sure of what you're doing. Okay, so just to wrap it up, this is all the material I had. But just to wrap it up, I would like to say, some people write code just for temporary use, and they don't want to put in effort to maintain that code. However, most of us want our code to be used over a longer period of time, and in that case, you should put in some efforts to maintain your code. The language or the platform that you're using to write your code will evolve with time. And it's a good idea to also let your code evolve along with that. And the compiler knows a lot about your code. It probably knows much more than you think. And it's trying to communicate to you via these warnings. So, don't be afraid to listen to it and go and fix your warnings. Thank you. Questions? Yeah, I finished up. Right? Yeah.
How about the performance? So if I introduce this row, this over, then the creation of this new list
So are you saying that if you, instead of using raw types, if you say list of string lst equal to new array list, then you have some performance implications? Is that what you say? Oh, for the conversion, you're saying. Oh, what he's saying is that method.
Yeah, well, in anything, there's trade-offs,
Yeah.
right? So if you want your code to be type safe, but you're dealing with raw types, the question is there performance implication in running through the contents of the list and doing instance subchecks? Well, of course, yeah, there's extra work, right? So there's a trade-off here. For many things, maybe that doesn't matter. If you're dealing with millions of lists, or a list with millions of items, doing checks on them, maybe it's not worth it. But then you run the risk of somebody passing in something erroneous and you getting a random class cast exception in the middle of your library. And so that's the trade-off. Yeah. So there's it's basically safety versus performance, and it kind of recapitulates the old Java. When C programmers went to Java, it's like, what do you mean? Java does array bounds checking? We can't do that, right? So, so it's a little bit of that over again, right? So, but it's a trade-off that you have to make if it's worthwhile or not to make that kind of change. Other questions?
Sorry. I just give it a shot on my code. It may reappear some old issue we have with deprecation. So when the interface has some deprecated method, I'm implementing the interface, so I have no choice to implement all the methods, even the deprecated one. The warning comes back and telling me I'm doing something wrong, I'm using deprecated code. And this used to happen in, I think, Java 4 or something like that, and so it disappeared afterward, but using the back all the warnings, make it really find the common side. So we never fell through this problem.
But you can put your method deprecated, remove the warning. In your implementation, put deprecated.
Oh yeah.
So the question was about you have an interface that's deprecated, and you have an implementation of that, and that throws a bunch of deprecation warnings. And yeah, I don't know exactly what the case is there,
need to
but
look at the code.
yeah, we need to grind through that. And deprecation is a tough one, and there's a bunch of things in the examples we showed of deprecation are ones I think that really should be deprecation, because you can, there are semantic problems with that stuff. There are a bunch of other things in the JDK that were deprecated for not very good reasons, and they're just irritating. And so, it's a bunch of trade-offs, right? In that case, you might decide to say, all right, Xlint all minus deprecation, because you could go through a bunch of extra work in refactoring. Again, there's trade-offs there. Do you want to do that work in order to gain some or little benefit?
Yep.
I've got a problem with the SerialVersionUID warning, because in many cases it actually encourages people to do the wrong thing. Because when the class does change, you actually do want to know about it, otherwise you'll have null values.
Yep.
Want me to
Go
do
ahead.
that? Yeah. Okay, well, so so the question was on SerialVersionUID and whether it encourages you to do the wrong thing by not having. Okay, so if you let the compiler automatically generate the SerialVersionUID and then you change your class, the SerialVersionUID will also change. And maybe that's something you would like, but. Okay. Well, hang on. Okay, so he says it is. Okay, in your case, if it is, then you go ahead and make that decision. But the issue is if the SerialVersionUID will change in surprising circumstances. For instance, if you add a getter method, that doesn't change the serialized form of the class, but it does change the SerialVersionUID. So now you've introduced an incompatibility in your serialization for no reason whatsoever. So okay.
If you change the mechanism to not change the number, if it's a trivial change like that.
Okay. Well, So the next question is, well, if I just add a getter method, why should that change the SerialVersionUID of the class? And there's a very long discussion, which I think I owe a blog post on this, but. SerialVersionUID is not the wire format of the serialized form of object instances. It is actually intended to be a serial number of the actual class implementation version. And the way they did that was to get as much public information through reflection as they could and then hash that all together. And so the idea was that if any possible change to a class could be an incompatibility, and so the SerialVersionUID would change. And so the other part of it is if you do declare a SerialVersionUID and you want to remain compatible, then what you have to do is make newer versions of the class be prepared for changes to the serial format. So yes, so if you add a new field, it might be null. Or if you remove a field, then information might get lost. So there's, okay, maybe we need to do a serial version compatibility talk at Java 1 next year. Oh, thumbs up from that. Okay, all right. All right, get ready for Java 1 next year.
So how do you convince your developers that they need to fix 14,000?
I'll give you an answer to that. Get an intern, ask him to do it. Then the next new hire, ask him to do it. The next new hire, ask him to do it. And the legacy continues. See, it's a good way to learn the code. So.
Yeah, actually, so what Kirchi said is true. We hired a summer intern and we had a bunch of projects. So so Kirchi is a relatively new employee on the team, and so let me go through the history. Historically, we knew there was a problem with warnings, and it's like, what are we going to do about that? Right. So last summer we hired an intern, and we had a variety of projects to do, and one of them was figure out something to do with these warnings. And that's what he did. So great. Guy named Sasha Bulgakov from Caltech did really great work. So he knocked off a couple thousand warnings single-handedly. And then we hired Kirchi, and she said, oh, for your next project, get to know the code base, clean up some more warnings. And so, in fact, we hired somebody else, and we assigned warnings to him as well. And so I was having a conversation with somebody this morning as well, which was, it's like, wow, this drudge work of cleaning up warnings. It turns out there is a surprising number of interesting and very, very subtle technical issues with some of these warnings. And so it's actually got legs. So, and actually we had management support for this too, because the JDK is as you know, it's an old code base, but it's a very, very long-lived code base. This is not something we're going to throw away next year. So, as the maintainers of it, it's in our own interest to keep it up to date and fresh. And so, this has been a long-standing issue of, what are we going to do about these? So we started to do something about it, and we got some interesting results.
So let me rephrase the question. wasn't there a manager who said, look, you could spend a lot of developer time, dollars, into fixing this, or we could just say, the code's working, why change it? This is a business problem.
Well, it doesn't take that long to fix those warnings. I would say, yeah. Yeah, I mean, you cannot do all of 14,000 in one day, of course, but nowadays the IDs are pretty sophisticated. They help you a lot, so it doesn't take that long to fix those warnings. I would say that personally, having worked on them. Yeah.
So you said most of the warnings were there because of the language change or API change, right? Going forward, JDK will have some API changes, language changes. Are you going through the same process again, or what's the
Lambda? We don't have any plan as of yet, but I'm not. Do you know of any new warnings that are going to come in?
I'm not aware of any new warnings. Now there are. I talk to the Lambda guys a lot since I do work on Lambda as well, and there are some cases where if you write a Lambda in a particular way and it can't do overload resolution in exactly it has come up to say, okay, in that case, issue a warning. But that would be only in new code that actually uses Lambdas. So I'm not aware of any new features that would be added that would cause new warnings to occur in old code, and that's the pathology that happened in Java 5. But there's always that possibility. That happened a bunch in Java 7.
Because.
Yeah, what was it? There was the. And in fact, there's something we didn't talk about today, but the auto closable interface that was added in support of try with resources in Java 7. There are certain usages of that will cause warnings to be emitted. And it seemed like a sensible thing at the time, and I discussed this with Joe Darcy, who is the spec lead on it, and he discussed it with the Xlint group, and they said, well, okay, we don't know what to do about this, so we'll add a compiler warning. Okay, well, so we're doing the warnings cleanup, we're looking at this, and saying, well, there's actually nothing that can be done about this warning, therefore it's a useless warning. So I'm actually, this hasn't played out yet, but my recommendation is actually to take out the warning from the compiler. So there may be things like that in 8, but now that we're sensitized to warnings, and we talked to the compiler guys, we're pretty close to them, so they're not going to go adding warnings gratuitously or anything like that on us.
You had a question?
Yep.
Going to the size of the challenge, you mentioned it's not that big a deal. Do you have an estimate of sort of how many person days work? So I realise you'll be doing it sort of pieces.
So I'll tell you what, getting rid of the warnings is not a big deal, but I guess if I sit for 3 hours, I have done it, knocking off 500 warnings is not a big deal. But the deal, what comes in is, everyone is because everyone uses this, our core library so much, everyone is very concerned about code compatibility. So when we go for code reviews, it takes a lot of time, but it's distributed. So I'm not doing the code review. 2-3 other people are doing the code review, and they tell me, I don't think it crept into my working hours as such. I could do it, offline, at home, on a weekend.
Process, I mean, you've got that many warnings distributed across your code base, the impact of refactoring and as you're going to touch.
Yeah, so it's not going to happen overnight. It's been 1.5 years, but we have only gotten rid of 6,000 warnings. There are around 7,000 still there. It's going to be a gradual process. It won't happen overnight. But what I would say is around 500 warnings. Whoever is knocking it off will take 3 or 4 hours, and then code review and everything together will be another 4-5 hours a day. If you just take number of hours, it takes a long time because people do it, during their free time and so on. So.
The other thing is the 80/20. You're going to be able to get rid of huge slews of warnings in one bit, but then you're going to find some really weird freaky case, and then that's going to take you a whole week. And then if you go and let's say it's not 80/20, let's say it's 95/5, you go and look at 5% of 1,000 warnings. Think that each of those 5% might be substantial. That's going to be a big cost nonetheless.
But
So I mean, is there a compromise? Is 95% reduction, target state truly zero?
I think we try to knock off everything. We go class-wise and package-wise. But then there are times when, people like Stuart will tell me, don't do this, leave it.
Yeah, there are a bunch of edge cases in there. Basically, the questioner was saying, there's 80-20 rule, so it's pretty easy to knock off 80%, but then there's the remaining 20, the remaining 19% that are harder, and then there's the remaining 1% that are intractable. And yeah, that's true. There's been some really weird special cases. And so there's this generics case that's really hairy, where we ended up casting something through a raw type and saying, okay, we'll just do that and just add suppress warnings there. So that's the thing, right? So first of all, there's no requirement that we get rid of absolutely every single last one. So there are probably a few warnings we've left in there because I don't want to garbage up the code because I actually think this is a compiler bug. I think there are 2 cases of that or something like that. And then there's some other ones where we do use suppress warnings, but quite judiciously.
So it sounds to me like that 1% of really hard warnings are things that are either bugs in the compiler, which we reported, or maybe latent bugs in your program. I mean, it sounds like those are more worthwhile from a perspective of learning the code than the other 95%.
Sometimes, I mean, it's like if you, in particular, in our code base, we have an interesting situation whereby, in order to get around threading, essentially, so a pub-sub mechanism where you've got 2 different data types being consumed by one thing, for the sake of doing transactions, essentially it's bounded around one thread, so we can't share the connection, we can't share the transactionality across, but it can take 2 different data types, and depending on the data type comes to the collections, it will choose what stored procedure is going to be. And in that particular situation, so you've got, I'm receiving data type A or data type B, so generic collection of A or B, essentially. In that particular situation, you can spend a long time trying to work out the correct way to do this. And in the end, ultimately we went through, right, so that we're going into the raw type for this. We'll have an overloaded constructor for this, whereby we'll do a comparison based on the inner class type, and depending on that, we'll route to the correct sub-handler. And we just couldn't find a good way to do it, and that will flag up like this.
Yeah. All right. Well, I'm not going to try to repeat the scenario there, but
it sounds like you learned a lot.
Yeah. That's what I was trying to.
Oh.
We tried.
Like, I think those hard ones, the 5% that you point out, that is where you learn a lot.
Yeah.
If you have the time.
So anyway, so just to try to recap that, so the audience member had a scenario where he's using generics of this type or that type, and I think there's some things you actually cannot represent in the generic type system. And so when you do that, you're going to make a cast and it is going to get a generic warning. One thing I would want to point to, there's over the years, the java.lang.class has sprouted a number of interesting cast conversion methods that will, like if you load a class dynamically from somewhere, you can say, as instance of or subclass of, and it will actually return something that is of the proper generic type. And so sometimes if you or another technique is to pass a a .class literal along with it, and then you can use the casting stuff. And maybe you guys tried that already, but sometimes if you use those techniques, you can actually really work with the generic type system, and the solution will just pop out. But if not, yeah, you would have to go as raw types or suppress the warnings or something like that. So just don't waste too much time on it, because these things do exist.
I guess they will be very times in trouble if they have some kind of parent type.
Yeah.
Actually, no, they don't in this case. So it's a low-level framework which other people should build on top of. So the idea is that you provide one dirty layer, and then everything above that is very clean, it's perfectly generic typed. But the framework itself is a very, very low-level piece of code to abstract away threading. They can be any type of.
Yeah.
So, on top of warnings, there's the checkers framework or the other one, find bugs. Is like knowledge testing and all that stuff part of your same effort, or is it unrelated? Or
No.
No, so this effort is just about warnings. The question was about other static analysis tools like find bugs, and then the checkers framework, which is based on some new annotation work going on in JSR 308. And so the checkers framework is very interesting, but that's still sort of work in progress. But the intent of that is to introduce new annotation types where you can add meta information about your code that will be checked by an outside framework. And that's very interesting work. And so we are doing, so other folks like in the languages team are working on that. It's very interesting work. But it's kind of, we're sort of on the trailing edge of stuff here. We're cleaning up old code as opposed to, working on new infrastructure.
there's no reason you couldn't add the annotations as you're fixing your old code.
Yeah. Well, so one of the problems is the annotations that are going to be used by these new checking frameworks, I don't think they've really been clearly defined yet. A typical one that's been kicked around is @not null. And so I want to make sure that this is never null, and that would be a good thing. But it's not declared anywhere in the JDK, and we don't actually want to start using it, because to use it we'd have to put it into the JDK. But it's not defined yet, so But eventually, yeah, I think this is something that we're going to want to do, is to go, when this stuff comes out, we're going to go on and want to add those kind of annotations and then clean up any issues that arise from it. And I suspect there will be that, because the checkers framework is all new and experimental and a research project, and they're going to want to run it over real code at some point, and we're probably going to, real code is actually going to expose bugs in it. So. I think it's a different effort, but I think it'll be a very interesting one, and I'm sure there will be some effort put into that over the next couple of years.
Here's another question. So suppose you're looking at one of your warnings and you decide that the warning cannot be fixed. Maybe it's a compiler bug, maybe your code is good. For whatever reason you can't. What do you have the procedure, besides saying adding suppressed warnings, to let other people know that this code is really good, even though it causes a warning?
So if we are adding an @suppress warning, we add a comment there. It's a standard rule that we kind of follow to describe why I'm adding that @suppress warning. We just don't go and add @suppress warning. That's the only procedure we have, I think. Nothing else. Nothing formal.
I think we're time.
Yep. Thank you.